Number 1, find all solutions to each equation. So these all are examples of zero product property or equations that zero product property can be used in because they are two factors multiplied by each other equaling to 0. So we know that anytime we have two numbers multiplied by each other that equals 0, one or both of those factors should equal 0. So in this case, we have x equals 0, and we also have that x minus 1 would equal 0. So this one is already solved for. So we know x equals 0 is one solution. Then in this second part, we can solve for x by adding 1 to both sides. So negative 1 plus 1 is 0. So this is gone. So we get x equals 0 plus 1, which is 1. So for part A, our two solutions are 0 and 1. For this part B, we have these two expressions. I'm just going to do these off to the side here. So 5 minus x equals 0, or 5 plus x equals 0. So in solving this one, I'm actually just going to add x to both sides because negative x plus x is 0. So we're left with 5, and then 0 plus x is just x. So we get x equals 5. And then here I'll subtract 5 from both sides. So 5 minus 5 is 0. So that's just x. And then 0 minus 5 is negative 5. So we get x equals 5 and negative 5 for part B. Then for part C, we again have these two pieces. So 2x plus 1 equals 0 would be one possibility, and x plus 8 equaling 0 would be the other. So if we want to get x by itself here, we can subtract 1 from both sides, which will leave us with just 2x on the left, since 1 plus negative 1 is 0. And then 0 minus 1 is negative 1. So this is 2 times x. So we'll divide both sides by 2 to figure out just x as negative 1/2, or you could have it as negative 0.5. And then we could subtract 8 for this one, which gets us 0 here. So just x equals negative 8 for our two solutions for part C. So negative 1/2 and negative 8. Then D, these two factors are exactly the same expression. So we only have one solution. So 3x minus 3 equals 0. We can add 3 to both sides. So that gets you 0 here. So just 3x. And 0 plus 3 is 3. So then to get x by itself, we would divide by 3. And that will get us x equals 1 for our one solution for part D. And then for part E, we've got these two pieces. So we'll solve each of those. So 7 minus x equals 0, and x plus 4 equals 0. So here I'm just going to add x to both sides. So then we end up with 7 equals x as one solution. And then we can subtract 4 here. So we end up with x equals negative 4 as the other solution. So 7 and negative 4 are the solutions for E. Number 2, rewrite each equation in factored form and then solve using zero product property. So remember that our factors, okay, so when we factor this, it's going to be a binomial times a binomial, and then we still have it equal to 0. So the two numbers that we put in need to multiply to give us 6 and need to add to give us negative 7. And when we multiply two numbers to be a positive, they're either both going to be positive or they're both going to be negative. In this case, they'll both be negative so that they can add to a negative 7. So the two numbers that multiply to 6 and add to negative 7, and you can do a factor list off to the side. So you could say, all right, negative 1 and negative 6 -2, and -3. So those are the only things that multiply to 6. And these are the ones that add to -7. So D minus 1 and D minus 6 would be our factors. Then zero product property, you're going to set those each equal to 0 to solve. And you maybe don't need to solve the equation because you maybe just know what D equals, but I'm just going to solve them off to the side in case anybody needs that. So we've got D equals 1 when we add 1 to both sides. We could add 6 to both sides here and get that D equals 6. So our two solutions are 1 and 6 for part A. For part B, we're looking for two numbers that multiply to positive 81 and add to positive 18. So X here, not D. So we know we're going to have two positive numbers because they need to multiply to a positive and add to a positive. So you want to think of factors of 81. Again, you can make a list if you want to. So 1 and 81. 81 is not divisible by 2. It is divisible by 3. 3 times 27. It's not divisible by 4 or 5 or 6 or 7 or 8, but it is divisible by 9, which is 9 times 9. And here's the two that multiply to 81 and they also add to 18. So we would have x plus 9 and x plus 9. And then this is the same factor, so we only need to solve one of them equal to 0 since we'll get the same number both times. So we can subtract 9 from both sides and we get that x equals -9 as our solution for that. Part C, now we need to multiply to a -60. And we need to add to a positive 7. So if we're multiplying to a negative number and we're adding to a positive, we need one of each number. So one of each sign. So one of our numbers is going to be negative and one of our numbers is going to be positive. So we're going to have a minus and we're going to have a plus. So then when we figure this out for our factors, okay, so for 60, you've got 1 and 60. One of them will be negative. So if we just think of subtracting these, okay, or adding a negative, this is going to have a difference of 59, which is not what we want. 2 times 30 has a difference of 28. We're looking for a difference of 7. 3 times 20 would be 60. 60 divided by 4 would be 15. 60 divided by 5 would be 12. So this has a difference of 11. This has a difference of 7. So here's the one we want. And if you exhausted your list, you'd also get to 6 and 10. But here's the one we want because this has a difference of 7 and we want it to be a positive 7. So we want it to be -5 and positive 12. So -5 times positive 12 gives us -60, and -5 plus 12 gives us 7. Then you can solve each of these. So u minus 5 equals 0. If we added 5 to both sides, we would get 5. And then we have u plus 12 equals 0. So we could subtract 12 to both sides and get that u equals -12 as our two solutions for that one. Then this final one is using decimals. So you may need to use your calculator to try to figure this one out. But 0.1, so 0.1 times 0.1 gives us 0.001. And 0.1 plus 0.1 is 0.2. So if we do this and we think about it as multiplying these, that equals the 0.01 that we need. And if we do 0.1 plus 0.1, that equals the 0.2 that we need for the middle term. So then we can just solve this and it's the same factor. So we just need to solve it once. So we'll just subtract 0.1 from both sides. So we get -0.1 as our solution. Number 3, here's how Elena solves the quadratic equation x squared minus 3x minus 18. Is her work correct? If you think there's an error, explain it and correct it. Otherwise, check her solutions by substituting them into the original equation to show that it stays true. So we see that she factored here, right? So she went from here to here to factor. So we know the two numbers she chose need to multiply to negative 18. So she chose negative 3 and 6. So when we multiply those together, we definitely get negative 18. They also need to add to negative 3. So the negative 3 plus 6 needs to add to negative 3, but negative 3 plus 6 adds to positive 3. So that's where she went wrong. Okay, so her signs are wrong. So she really needed it to be x plus 3 times x minus 6, because 3 plus negative 6 would give that negative 3 middle term that we wanted, which then gives us x plus 3 equals 0, so x equals negative 3. And then x minus 6 equals 0, so x would be positive 6 to solve that equation. So she was just off by the opposite, so did her signs wrong there. Number 4, Jada is working on solving a quadratic equation as shown. She thinks her solution is correct because she's substituting 5 in for p into the original expression, and it gives her back 0. Now, one thing to note here is that this original expression is different than this one. So there's an error in the book. So maybe yours has been changed since I screenshot mine, but this part right here should say p squared minus 5p equals 0. There shouldn't be an x there. If there was an x, so if yours is still printed like this, she's wrong because you can't factor it with those two different variables. But really this should be a p. So yours has probably been changed now that you're watching this video, but if it hasn't, just change that. And so what happened here is at this step, okay, so at this step where we have p times p minus 5 equals 0. So she factored this correctly, because if we multiply p in, we would get p squared minus 5p, which is our original. So this is good. But when she goes to the next step, she loses this p because she divides both sides by p, and we don't want to divide by a variable. Okay, so we don't want to do this because otherwise we lose a solution. So she should be doing the zero product property where she puts the first factor p equal to 0 and the second factor p minus 5 equal to 0, so that she sees that 0 will work as well as 5. So there are two solutions. You don't want to divide by a variable. Instead, you want to do zero product property. Number 5, choose a statement to correctly describe the zero product property. So if a and b are numbers and a times b equals 0, then both a and b must equal 0. Well, that's false. You don't have to have both of them equaling 0. Neither a or b can equal 0. Well, that's false. In order to multiply two numbers together to equal 0, one of them has to be 0. There's no other way to do it. And so that's answer C, that either a equals 0 or b equals 0. Both could equal 0 as well, but they don't have to. So both must is not true. So a has to be 0 or b has to be 0 or both. And then a plus b must equal 0 is not true. And you could think of that because if you did a as negative 2 and b as 2, those add to 0, but they don't multiply to 0. Number 6, which expression is equivalent to x squared minus 7x plus 12? So we know that our two numbers have to multiply to equal 12. And then we also know that those same two numbers need to add to equal negative 7. So if we take a look at these numbers here we have 3 and 4. So 3 times 4 equals 12 is definitely true. But 3 plus 4 does not equal negative 7. So then this part A is false. Okay, so A is wrong. For B, we have negative 3 and negative 4. So negative 3 times negative 4 is positive 12. So that's true. And then negative 3 plus negative 4 is negative 7. So this is true. So B is the equivalent expression. For C, they definitely multiply to 12, but 2 plus 6 is 8, not negative 7. And negative 2 plus negative 6 is negative 8, not the negative 7. So B is the correct answer. Number 7, these quadratic expressions are given in standard form. Rewrite them in factored form. So they're not equal to anything. So we're not going to be solving. We're just going to be factoring. So we're just going to be writing them as a binomial times a binomial. We see that they multiply to a positive and they add to a positive. So that means both of these are going to be pluses. So what two numbers multiply to 6 and add to 7 would be 6 and 1. So 6 times 1 is 6. 6 plus 1 is 7. So that would factor to x plus 6, x plus 1. This next one is very similar, except for now it's going to add to a negative 7. So that means that we would want two negative numbers. So negative 6 times negative 1 is positive 6. And then negative 6 plus negative 1 is that negative 7. Then for C, we're still multiplying to 6, positive 6, and we're adding to negative 5. So we're going to want two negative numbers, but no longer does 6 work, 6 and 1, because 6 and 1 gives us 7. So what else multiplies to 6 is 2 and 3. So negative 2 times negative 3 gives us that positive 6 we want. And negative 2 plus negative 3 gives us the negative 5 that we want. So this will be x minus 2, x minus 3. So then for this bottom one, we just want a positive 5 on the inside instead of a negative. So now we'll have x plus 2, x plus 3. Because again, positive times a positive. So positive 2, positive 3 gives us that positive 6 at the end. And 2 plus 3 gives us that positive 5 in the middle. Number 8, select all the functions whose output values will eventually overtake the output values of this function. So this one's a quadratic. So what we're looking for is exponential functions. Okay, exponentials will eventually take over quadratics, and we definitely want it to be exponential growth so that it's, even if it's starting slow, it gets really steep really fast. So exponential growth, not decay. So part A we see as an exponential with a growth factor of positive 2. So that one's growing. B is an exponential function with a growth factor of 5. So that's growth. C is a quadratic. So that's not going to eventually overtake it. I mean, it already is over it. So it's not going to eventually overtake it because it starts above it anyways. But I guess it won't stay because it's only 1x squared versus 25x squared. But a quadratic won't overtake a quadratic. D is an exponential, and that growth factor is 2.5. So that's going to be exponential growth, and that will eventually overtake that. E is an exponential because we see the x as the exponent. The growth factor is 2, so that's exponential growth. And then F is a quadratic, again, starts above it, except for only has a 2 in front of it. And so this one's going to be overtaking it instead. So A, B, D, and E would work. Then number 9 is a piecewise function defined by these rules where the top part is less than or equal to -2 for your x's, and the bottom is when x is greater than -2. So find the value of p at each input. So for this one, we have x equals -20 that we want to be plugging in, and -20 is less than -2, so that's going to go in this top part. So we're going to be using the x minus 1, and x is -20 minus 1 gives us -21. Then for part B, we have -2, which again is less than or equal to -2. So this is going to be going in our top function. So this one, our x is -2 minus 1 gives us -3. For part C, it tells us that P is 4, P of 4. So here we have x equals 4, which is bigger than -2. So that's going to be going in this bottom part of our piecewise function. Any x's that are greater than -2 go in the bottom. And so our x here is 4. So we'll be doing 2 times 4 minus 1. So 2 times 4 is 8, minus 1 is 7. And then part D gives us x equals 5.7, which again is still greater than -2. So that's going to be going in this bottom function of 2 times our x value minus 1. So 2 times 5.7 is 11.4. And then minus 1 is 10.4.